Hello, Year 9. So we're going to go through the writing formulae and equations test that you did last week. So please make sure that you're going through it with a green pen and you're writing down the corrections on the paper as well. So for question 1, we're talking about sort of chemical formulae and you're writing the names of the chemical formulas down. For AI, you've got NaCl, that is sodium chloride. Now the "ide" is really important there, so make sure it doesn't say chlorate. And make sure you haven't missed the H in the chloride as well. There were sort of common mistakes that came up. For II, where it says BF3, that is boron fluoride. Again, ide really important there. And also when you check your spelling of fluoride, it should, if you can see the word flour, F-L-O-U-R, that's an incorrect spelling of fluoride. It's F-L-U-O-R. For III, this is calcium carbonate, not ide, because there's oxygen inside of there as well. So if I've allowed an answer, will you write down the correct answer as it is on this mark scheme? Okay, so Bi, so we're writing down the number of each type of atom in the following formulae. So in CO2, which is carbon dioxide, there is 1 carbon atom and 2 oxygen atoms. In II, which is actually ethanol, you've got 2 carbon atoms, 6 hydrogen atoms, and 1 oxygen atom. I allowed you to say sort of 5 hydrogen and then 1 hydrogen at the end, but you could just put them together to make 6. Now for III, this is where some of the mistakes started to come in. So anything in brackets is times by the number on the outside. So inside the brackets we've got NH4. All of that is going to be times by the 2 on the outside. So it's going to be 2 nitrogen atoms, not 1, and 8 hydrogen atoms, not 4, and then 1 carbon atom and 3 oxygen atoms, which are on the outside. So be careful with that. Everything inside the brackets is times by the number on the outside. Moving on to question 2 then, we're looking at the valencies of different atoms in the periodic table. For A, we've got oxygen. So oxygen is in group 6 of the periodic table. It will gain 2 electrons to get a full outer shell, so it has a valency of 2. Nitrogen is in group 5 of the periodic table. It will gain 3 electrons to get a full outer shell, so it has a valency of 3. And hydrogen is in group 1 of the periodic table. It will lose 1 electron to get a full outer shell, so it has got a valency of 1. Okay, let's look at question 3. So it says, write down the formulae of the following compounds. There were lots of mistakes in question 3, so please make sure that you do really self-assess these and do actually write down the correct answers as well. So the first one is for potassium iodide. So potassium is in group 1 of the periodic table, so it has a valency of 1. That's why I've written the 1 underneath. And the iodine also has a valency of 1 because it's in group 7. It'll gain 1 electron. So when we cross those over, times the potassium by 1, the iodine by 1, we get the formula Ki for potassium iodide. For B, we're looking at magnesium chloride. Inside of magnesium chloride, we're going to have magnesium atoms and chlorine atoms. The ide means that there's nothing else inside of there. So magnesium is in group 2 of the periodic table, so it has a valency of 2. And chlorine is in group 7 of the periodic table, has a valency of 1. We cross those over, times the magnesium by 1, the chloride by 2, and we get MgCl2 as a formula for magnesium chloride. For C, beryllium oxide, things are slightly different. So beryllium is in group 2 of the periodic table. It loses 2 electrons to form to get a full outer shell, so it has a valency of 2. And oxygen is in group 6 of the periodic table, so it will gain 2 electrons, so it also has a valency of 2. Now if you've written Be2O2, I completely understand where you're coming from, because when you cross them over and times them by each other, that's what you would get, but you simplify those numbers, and 2 to 2 simplifies to 1 to 1, so you actually end up with BeO. So 1 beryllium atom can give 2 electrons to 1 oxygen atom to form beryllium oxide. Now D was worth 2 marks, so the other 3 were all worth 1 mark each. D is worth 2 marks. We're looking at aluminium nitrate. So the first mark is for realizing that you've got aluminium inside of there, and not just nitrogen. It's not nitride, it's nitrate. Now that's the formula NO3. So 1 mark for saying Al and NO3. The second mark will come from getting the right sort of numbers of those inside of the compound. So aluminium is in group 3 of the periodic table, so it has a valency of 3, and the nitrate ion has a valency of 1. We times those over, and you get Al, one of those, and then we put the NO3 in brackets because I'm going to times all of those atoms by 3. So 1 mark for getting Al brackets NO3 close brackets 3. E then goes back to just being 1 mark, so iron 3 sulfide. The bit here is you need to realise that the Roman numerals after iron tell us its valency. So iron has a valency of 3 and sulfide has a valency of 2 because it is in group 6 and it'll gain 2 electrons its full outer shell. We times those numbers over and we get Fe2S3. I was really pleased actually that none of you wrote I or IR for iron. You all used Fe, so that was fantastic. Well done. F then, ammonium sulfate. This is also a 2 mark answer. The first mark is for getting the NH4 for ammonia and SO4 for the sulfate. So ammonium has a valency of 1 and sulfate has a valency of 2. We cross those over and I need to times the NH4 by 2, so I'm going to put that in brackets and the 2 down at the bottom, and then there's only 1 sulfate, so it's just SO4. So the answer is brackets NH4 brackets 2 SO4. Not many of you, possibly even none of you actually, did it the other way around, but it is okay to say SO4 brackets NH4 brackets 2. You can have it on either side. It doesn't actually make any difference. Question 4 then is about state symbols, and you need to match up the state symbol to the best description of it. It does say note that you do not need to use all of the description, so there should be 1 line coming from each really. Now it gave you that S in brackets means solid, so that's not a mark, but there is 1 mark for L in brackets being a liquid, G for meaning gaseous, and AQ for dissolved in water, which stands for aqueous. So there shouldn't be anything going to compound or anything to a mixture of substances, and it was 1 mark for each of those lines. Okay, so question 5 is on balancing equations. As I said in lessons before, any multiples or fractions are absolutely fine. So it doesn't matter if you've got exactly the right answer, as long as they're in the correct ratio, that's absolutely fine. So for 5a, I've got zinc reacting with oxygen to make zinc oxide. I've balanced that by putting a 2 in front of the zinc atoms and a 2 in front of the zinc oxide, which balances the number of zinc and oxygen on both sides of that equation. Lots of you just put a half in front of O2, so ended up with kind of a 1, a half, 1 as we go through the reaction. That's absolutely fine. Yeah, as long as it's in the right ratio, that's absolutely fine. For B then, I've put a 2 in front of the hydrochloric acid in this reaction, which balances my equation. For C, I've got 2 Fe and 3 F2 going to make 2 FeF3. Again, multiples and fractions are fine. I think one of you wrote 4, 6, 4, absolutely fine, doesn't matter. Now D gave you lots of problems. D is a reaction that you're going to see later on in year 9 actually. It is something that I think that you should probably learn if you didn't get it in this test. It should have been 1 iron oxide and 3 carbon monoxide going to make 2 iron and 3 carbon dioxide. Lots of you have tried to balance it with even numbers, which didn't seem to work. So the carbon monoxide and carbon dioxide had to be the same number. A little tip then is that if an even number isn't working, maybe try an odd number and just see if you can make it work that way. That was a challenging one though, and lots of you struggled to balance that one, so clearly it's difficult. Okay, last but not least, question 6. We're writing balanced symbol equations for each of these reactions, and we don't need to include state symbols, but actually we can talk those through as we go through this, and you can add them to your notes as well. So 6a says that methane gas, which has the formula CH4, burns in oxygen to form carbon dioxide and water. Now there are 3 marks for this. The first mark is going to come from the formulae of the reactants being correct. So in this instance, it's going to be the formula of CH4, which is given to you, and O2, not just O, O2, because oxygen is diatomic, it's one of our gen molecules. So that's 1 mark. The second mark is for the formula of the products being correct. So it tells you in the question that we make carbon dioxide and water. So having CO2 and H2O is your second mark. The third mark then comes from balancing that equation. And like in the previous question, any multiples or fractions will do. I've chosen what I think is the simplest, where you've got 2 oxygen and 2 waters, which will balance out the number of atoms on both sides. So that's where your marks are coming from. Now the state symbols for these, every single molecule here is going to come out as a gas. So methane is the gas in your Bunsen burner, oxygen is a gas, carbon dioxide also comes out as a gas, and remember that water in a fire is going to be above its boiling point. It will also come out as a gas, not as a liquid. For 6b then, this is a reaction that we have done this year. So chlorine solution is reacting with sodium bromide solution to produce an orange solution, and we're writing a balanced chemical equation for that. So remember that your halogens are diatomic, so the chlorine that's reacting with it will be Cl2. Then sodium bromide is going to be NaBr. Use your crossover method to figure out the formula of that. That was a common mistake. It's not NaBr2, it's just NaBr. So the formula of Cl2 and NaBr is Mark 1. Mark 2 then comes from the formula of both products being correct. So the formula of bromine which is produced is Br2, and sodium chloride solution that's made is NaCl. So the second mark comes from the formula of both products being correct. The third mark then comes from balancing that equation. Now I've done it with 2's in front of sodium bromide and sodium chloride. You could just as easily, and lots of you did this, a half in front of Cl2 and a half in front of Br2 also works. So any multiples or fractions works. For state symbols then, it didn't need this for the mark, but just out of interest, all of these things are in solution. Okay, so you've got chlorine, sodium bromide, bromine solution, and sodium chloride. Additionally then in the question it says that an orange solution is formed, so we should know that chlorine forms kind of a pale green solution and bromine will produce an orange solution. So actually the orange solution is coming from the bromine that is produced, and it's showing us that chlorine is more reactive than bromine because it can displace it from that compound.